Good evening, everyone. Sorry for the delay. I was actually got busy with another meeting. So let us start. So this is your day one here for the CCNP CCI Security Score module. So we will be first going through the. Let me tell you which certificate we would be covering here. You already are aware of this. So it says a score module. The exam code is 350701, score version 1.1. These are the outline and the lab outline, the topic overview. For the detailed certification information, you can also go to the Cisco's training for CCNP CCI. Explore exam and training. This is the score link. So you can find all the exam topics over here. Okay. So as usual, there are the six chapters and all has their own weightage. So we'll start with first few topics for the day. Regarding to the access material, you guys have already received the welcome kit email, right? So which has the access to the LMS. You have class 0 where you will find all the notes and the home lab downloadable files. You have the remote lab access. You do have the home lab assistance or home lab instruction provided in the welcome kit and also the support deal. So if in case you have any issues with any password or if you need any help or assist on the home lab setup, you can write an email and the backend team will help you with that. Okay. Regarding to the so let me just close this. So regarding to the notes for the score, as I told you, it's already present in the present in your LMS portal. So let me show you that portal here. So you will find the class 0 and this is where the reading material is. Let me open this. Okay, so you have the official test book if you want to go through the official reading material. And there is the notes that I have prepared. So you can find topic by topic all the notes kept here along with the lab workbook. So whenever the topic was discussed, the lab is just below that particular topic. Okay, and the second link is towards the home lab setup. So it's a mega download link. You can download the file from this. So let me see the file size of that. Put the password that's provided in the notepad. So yeah, it's a very big file. It's around 50 GB. You might take at least 3-4 days to download it. Once you download, let me show you how does this score looks like. Score Score Lab. This is not the lab. Let me check. Okay, score. So this is how the lab would look like. Okay. Now just as an overview, you will find all your iOS related devices here. So we will be utilizing this section for the attacks and the common attacks learning. So you can see there is a Kali Linux node here. Then over here we would be utilizing for the VPN studies. This section we will be utilizing for WSA, web security appliances. And you have this section from the VPN perspective, once again, like MPLS kind of thing. And over here also you have some VPN concept. Okay. And for the ASA cluster and context and ASA HA failovers. So these are the ASA boxes which you see here. These are all ASA boxes. So we can have the active standby concept and all the configuration related to firewalls, and this we can utilize for the context and for the VDC concept. So this is the one. This is the management PC. So you can take the graphical interface of IPS device, and you can take the access of the Kali Linux from here. There are also FTD and FMC. So you see these are the FTD boxes. Okay, so these are the FTD box and this is the FMC box. The fonts may not be visible, but when you have your access, you can verify. These are FMC, FTD. You have WSA here. Okay, and this is for the private VLAN section. So this is how the lab it is. And if there is any changes or any add-on, then I will be making those changes and I'll be giving you the updated UNL. This section is for some API studies for the from the automation perspective. So this is how the labs look like as of now. And if there is any topics to be introduced or any notes to be introduced, I will be doing that. If you want to also make any changes from your side, feel free. There is an option to unlock this, and you can add or remove the nodes. So the nodes have, as of now, the Windows Server, Windows Management PC, WSA, Stealth Watch, Firepower, ESA, CSR, which is iOS XE, ASA-V and ASA, Cisco ICE. So there are all the images that we need from the security perspective. Okay. So if I want to even enhance this by adding Cisco ICE and some MS server and I want to showcase some lab, then I'll be making some changes on the existing setup. So on the initial days, we may not need any modification, but as and then we proceed, we can do that. Okay, now going further, let us see from the topic, what do we have? So you guys are already aware of the certification links and uh, the etc. But if you want, I can once very quickly start with this. So this is where the link where you will find the CCIE exam formats. Okay, all the links I've kept it on the first slide so that you can go ahead and check that. So this is for the certification link. This is for the training and certification. This is for CCNP. This is for the SCOR paper. And some time back there was a change from version 1 to version 1.1. So this is the link about that. And you want to see the hardware list for the CCI, then this is the PDF for that, which will have all the updated list. Okay, so it's a downloadable file. It will download on your local machine. And these are the practice lab. These are the blueprint. Okay, so that is from the exam pattern. Now coming from the topic, first topic we should understand that why security and how do you do the device hardening on the Cisco router, switch and ASA firewalls, right? So that is the very first thing in the CCI security or CCNP security, like how you safeguard your data. So what is data basically? So data is nothing but piece of information. So it could be username, password, IP address. It could be any confidential data of your protection. So what are the chances of getting these data leaked? You are not going to you are not going to do uh, push out the data as such, right? There could be a weak point in your network. Might be you are making use of the traditional configurational methods. Might be you're making use of a very weak algorithms. Might be you're not utilizing the best practice as advised by Cisco. So there could be n number due to which the network is compromised and the people as a backdoor activity can get into your network, steal the data, put the server in a non-functional mode, or cause some virus attack. So that can there can have multiple reasons for that. So these are some device hardening method. So if you check from the Cisco router perspective, these are some methods that is listed. So you need to enable SSH versus telnet, because telnet is a pure plain text mechanism. If you have a Wireshark, you can easily check the packet here and see entire thing, like IP address, the device information, the device target release, and all the things that is been happening here. So we go with SSH because the packets are encrypted packet. They have a better algorithm so that the man in middle do not open up the packet here. Similar way you can enable the AAA concept, which nowadays is very common, and you can have some rules, thumb rules for setting up the password. Say for example, you want minimum 8 characters, you want some special characters along with that, you want a combination of uppercase and the lowercase, you need a alphanumeric. So you can make a way to have a stronger password rather than a very common password ABC123, right? Or 123 till what, till 0. So we can avoid that concept. Similar way, the device logging and auditing. So it is very important to know who has logged in, who has done multiple failed attempts, failed login attempts. So you can check, or you can be aware of what is going across. So if you have a device R1, if you see some brute force attack, that means someone trying to log in an automated way. Okay, he is trying all the possible combinations to get into that. If you see, there are lakhs of request coming for the logging purpose, and the credentials are failing. So it is important to have a logging and auditing enabled, so that you can always see. And if you find that source IP is coming from certain country or certain fixed IP, you can take a measures to block that particular IP. Or you can also make some prevention mechanism inside the device, that if you get someone accessing for, let's say, for more than 10 packet, you don't reply to their SYN packet now. Okay, you can just stop the acknowledge packet sending to them, so that to avoid any DOS and DDoS attack. So that kind of prevention mechanism you can utilize. Then the access list, you already know what is access list and why do we use this. In case if you have a server and you just don't want to allow all this possible people, so you can limit it to whatever you feel like you have it in your network. Might be /24, or might be /30, or might be a specific IP alone, 168.1.1/32. So a single IP. Most of the time, in the protection, we don't give access to a complete 24 or 22, etc. We take it on a request basis. So I get a request to unblock the port on a particular service port number, and then I do it only on a PC to PC or a user to user itself. If I get a request, if I get a ticket from this user to allow this with the manager approval, then only I'll allow this person to reach this. Otherwise, I will just deny all the other traffic. Okay, so that is how you can just see whom to allow, whom to deny. Similar way, disable unnecessary services and protocol. Now, what does this mean? Say, for example, you have a router, okay, that might be running with lot of protocol or services. Say, for example, you have HTTP enabled. Uh, you have something enabled for, let's say, SNMP. So you have something enabled, let's say, for mm, like let's say TCP UDP protocol. Okay, might be you don't need them. You don't need them, but by default they comes enabled, and there is a chances that can lead to some security breaches. So it is advisable that you can turn that off if in case of not needed them. So most of the time this will cause you some sort of vulnerability issues. So we can turn that off. We can remove, we can disable them. Whatever is not needed, we can disable. So that is what that says, that you can remove those you can remove the unnecessary services and protocol if that is not needed. The next one is VPN. So why you need VPN? You need a secure mechanism to talk between two different branches. So you have one branch in Bangalore, and second one, let's say, in Mumbai, right? Let's say you don't want to get into a very costly MPLS or any other ISP solution. So the best option is that you might be on a shared infrastructure, shared internet infrastructure. Okay, you can build your own VPN tunnel here. So you can build just your own VPN, IPsec VPN site-to-site tunnel, and all your packets will be now transmitted across this. Now, this packets can only be encrypted and decrypted by these two devices only, where the VPNs are getting terminated. We call the terminology VPN termination. So wherever the VPNs are initiated and terminated, only those two devices are aware of the encryption, hashing algorithm, PFS, DH group, the pre-shared key, and they can only encrypt and decrypt and pass it on to the LAN segment. So if you have a user here who wants to reach a server at another branches, so your traffic will be encrypted over the tunnel and go to the server and just come back over on the same tunnel. So the encrypt and decrypt of those uh, packets on the tunnel is being taken care by the VPN algorithms that you've set it. So that is also a way to secure your data traffic. Going to the seventh point, SSH version 2. You know that SSH comes in version 1 and version 2. By default, this is enabled. Okay. But as soon as you enable as soon as you enable SSH, what happens is anytime you just go and do IP SSH, you will see that version 1.99 will be enabled. That means it's a backward compatible. Version 1 and version 2 are backward compatible. Now, this is a older version. It might have a very low side of algorithms when compared to V2. So as the best practice suggests that we make it version 2 by setting up this CLI command. Okay, so that is what it says, version 2. And then always regularly update and patch the firmwares or iOS images, because as you know, the things goes old, outdated, it becomes more vulnerable to attacks and can cause the backdoor attacks, or there can be the algorithms which are now very weaker or outdated. So it always recommend to have the updated version. Similar based RBAC, which means role based access. That is a way to prevent any unauthorized access. So let's say you have you want to give only the read only access. So feel free to create this profile and map to all those new people who have just joined you. You want to give a administrator access to someone who wants to fetch the report and do some more items. So you can create this profile. So it's a role-based access. Whom to give what kind of access. So you can make use of Cisco ISE and configure the different teams here. So the sales team can do this, the finance team can do this many actions. So it all comes under RBAC role based. IPS is a module. So earlier, what used to be done was, let's say if I have a module or a chassis, so I could insert the IPS line card to that chassis. It's called intrusion prevention system. So we can insert that. Nowadays, we get the dedicated IPS and IDS. So let's say if I have IPS and IDS, it's my first step of security mechanism where it can sense the DOS attack, or can sense the blacklist IPs and give us a report stating that we are getting an attack, or we are getting continuous attack from this particular IP, and the network team can then blacklist those IP behind the firewall so that we can close or we can stop the connection from them. So there are two types of module. One is IPS and the second one is IDS. So this is prevention, this is detection, and we use it especially by the SOC team, IT SOC team. So there will be a SOC team who will be working on the IPS IDS, will fetch the report, and pass it on to the network team saying that this IPs needs to be blacklisted. And then we go and check which firewall is facing towards the fan and put all these IPs on a blacklisting section. Control plane policing. Now what happens is, let's say if I have a router, there are three planes. You have a control plane, you got a data plane, you got a management plane. Now, most of the routing protocol traffic decision happens on the control plane. All your OSPF routing table, BGP routing table, right? All the protocol decision making happens in the control plane. So, for some reason, let's say if someone attacks on a control plane for some reason, and this is all exhausted now. So what would happen when a genuine protocol traffic is entering to this box? Now due to the overhead, due to the attack, now this device is not going to process the genuine packet, right? So what we do is we can apply some prevention mechanism, COPP. This is actually nowadays a topic under EI as well, enterprise as well as in the SCOR topic. So what we do as per the COPP is I will write a condition that if I receive the packet more than 8,000 BPS, okay, and a packet more than let's say 1,600 or 1,500 bytes, if I want, I can drop it immediately, or if I want, I can put them under queue so that if the traffics are clear, then the remaining traffic will be getting pushed upon. So there will be very less chances of congestion and less chances of slowness, etc. So if you want, you can completely drop it. If you think you don't want to drop, but you will prefer going with queue, then you can queue as well. So this is to prevent your control plane uh, going exhausted due to any man in middle or any sort of attacks happening on the control plane of the device. Okay, COPP. And then the next one says disable unnecessary interface port. So this is very common practice. If you have, let's say, 8 ports and you find that 4 are unused, normally what we do, we just do the admin shut. So I go and do the shutdown command. And if you want, you can put it under the description that it's a spare port. Okay, why we do this? Because we don't want we don't want someone to connect a cable to a vulnerable PC. So we don't want someone to connect it to something which we are not authorized to. So it is better that from a software level, I does the shutdown. And in case I need it, I can use this for some purpose, and I can put the description like a down link to whatever device or whatever switches. I can mention that. Okay, so you can unnecessary interface port, you can disable them. The NAT is a common practice because let's say you have a router and you have these LAN users, and if they want to go out, they will never carry the private IPs, right? They will take the NATed IP from the configuration that you have prepared. So NAT, in the sense, you will have to buy some public IPs from the ISP, and you can configure in the outside interface. So whenever a LAN user wants to connect to the ISP, or there is any need for uh, a customer to reach to your server. So if, for example, your customer wants to reach to your server from out to in connection, so you cannot give him a private IP 192.168.1.10. This IP you cannot give him because that IP is non-routable. You have to give him a public IP, a NATed public IP. So when he types that, let's say if he is doing FTP, or if he is doing HTTP, or he's making SSH from outside, so he'll make it on the public IP, and the NAT router knows the NAT translation where to where it is been converted. So that public IP will check the NAT table, will see that it is been translated to this private IP, And that's how you protect your private IP from the outside world, and also your private IP is kept secure. Okay, you don't want anyone to know what IP schema you are utilizing. You don't want your private IPs to be directly exposed with any outside users. That's why we give a public IP that will be limited to the boundary. Unicast reverse path forwarding, URPF. Again, a topic which is present in EI as well, CCNP EI. So this is one of the mechanism to avoid the data plane uh, resources. So you know what happens in the case of router. Let's say if a packet enters here, the router will check the routing table and then push it outside. That is the work of a router. It is not going to check which source is sending that, right? It never checks who is the sender. Now, what if it was a ROG machine? Okay, it was a ROG machine, and who is trying to send this to certain destination. So with the URPF, what we normally say that we are now going to check the source as well. The source is also checked if it is the genuine or not. And we can also set the condition if I receive the message or if I receive the packet from this source, then only I will apply. Or if I receive the source from this interface, then only I will apply or I will push it. So it's a unicast reverse path forwarding, and disable source routing and directed broadcast. So that means to avoid unnecessary uh, routing and unnecessary broadcast, you can disable this. These are usually enabled in the devices. As we said, we will disable all the unnecessary services and the protocol. So this belongs to that category itself. So if there is anything which you can disable, you can disable. Okay, who takes the decision? That is by your cyber security team or your network security team. When they scan, they come to know that there are few things which are non-compliance, then they will take the needful measures. Okay, so these are from the hardening method, device hardening method.
So, question
Yeah.
on 14, how does it verify the source? Is it through ping or DNS?
Okay. See what happens in URPF. So it's kind of ping itself. So these are the commands to enable that. So there will be a unicast packet source reachable via any. Okay, so you will be sending a unicast packet to reach that IP. So this is how your configuration would look like. Unicast source reachable via any. So there are two types. One is called loose method and strict method. Both has its own configuration. It's very simple configuration, 2 to 3 line. See, unicast reverse path forwarding is a mechanism to validate the source IP of the packet. A router configured with URPF performs a reverse path lookup in the forwarding information base to validate the presence of the source IP. If the source IP is listed in the table, then it indicates the source is reachable and valid. If the source is not located in the FIB, then the packet is treated as malicious and it is discarded. Okay, and this is the command to enable that mechanism. Okay, you must configure both IPv4 and IPv6 command for URPF to work. If you're not using version 6, then you can only enable version 4 there. So this is the scenario for XR devices. So for a XR devices, this is the configuration. For iOS and XE also, it is almost the same type of command only. Verify unicast source reachable via any. Okay, so there are two types here, URPF, loose and strict. In the loose, you will only see one criteria. In the strict, you will see two criteria. Okay, let me tell the criterias. So in the loose method, it will only check the IP only. Okay, it is only going to check one thing, whether the source IP is present or not. Whereas in the strict mode, so this is for the strict mode. In the strict mode, I think it has taken to URPF. Yeah, so for the strict mode, it will see the IP address at the receiving interface must match the routing entry of the interface. Packet must be received at an interface that has the best route to the packet source. Okay, so that is one condition. And the second one is that it is receiving on the same interface. Whereas in the loose method, you're only checking the source IP, but you're not bothered if you're receiving on the same interface or not. Whereas in the strict method, the second criteria is that you are going to check if you're receiving in the same interface ID as well. Okay, so that is how that there are two modes in the URPF, strict and loose method. So any other question before I go to next topic?
So yeah, Sagar, just want to know that, if you enable that the URP of any potential slowness going to happen in the network, or or this check will happen only once and then or is that going to happen uh every traffic
Yeah,
to
see,
the route?
once you enable this, it will be happening for all the packet that is received for that particular interface. Okay, if you see the configuration, it is done on the interface level. So whichever interface you allow this, it is going to be activated for that. So you go inside the interface and then you put the verify command. So you need to do this especially on the routers, wherever you expect to see the routing traffic. Okay, exposed to internet or exposed to the routing traffic, you can allow or enable that thing. This is the flow diagram. What happens and what it checks. URPF validating IP source address. So the routing table is this table. adjacency table. Now this is the packet arrived. If okay, RPF passes the packet to be forwarded by chef. RPF checks to see if the reverse path for the source address matches the input port. This is in the case of the strict, when two things are checked, and then only it will allow. Otherwise, it will just drop the packet, discard the packet. Okay, so like this, it will just drop the packet. Okay, any other question? The same thing is being mentioned for Cisco switch. I'll just go ahead one quick time. SSH, disable telnet, strong enable AAA, logging and auditing, ACLs, unused switch port, disable unused switch port, enable port security. Yeah, this is a add-on now, because now we are talking about switches. When you have switches which connects to the end devices, let's say PC or servers, you can come up with something called port security. Okay, so you can specify that you can actually associate the MAC address. So let's say you have a MAC address. So you can say that on this, you want to only allowing this device only. Or you can also specify that in this you can expect a max to max 4 MAC address from any user. So might be this got disconnected. There is another person, or might be there is an access point who is giving 4 or 5 MAC address here. You can only allow 4. More than that, it will cause a violation, and this switch port can uh, go on a error disable mode or a violation mode. So that it don't be in an active state. So that's a port security. Version 2, upgrade of the softwares. VACL, again, this is something which we utilized in the Cisco ISE concept also. VACLs are nothing but, if you have a switch, you want to apply some policies, okay, from Cisco ISE. Let's say there is a salesperson, a sales team. He is connecting via computer to the switch. Switch will make in return the AAA and get that VACL downloaded. So whom can he reach, whom can he not reach, is what in the VACL is being declared. It's called VLAN access control list, where I can say that this person is not allowed, even though he is on a VLAN, let's say 10, but I don't want to allow him on certain servers that is hosted on that VLAN 10. So that is a VLAN access list. .1Q, secure trunking, BPDU guard, root card, and CDP. Okay. Disable the CDP. It is basically, why disable the CDP? Because this carries lots of information. The neighbors, the switch port, the version of that devices, which can be, a potential information for someone to check and get the vulnerability. Say, for example, I tell you my device is 3850 and it's running 17.9.6. It is not a rocket science to go and check in this version what are the backdoor vulnerabilities, or I need to check what are the security breach possible in this. So there are a lot of document. If you ever checked Cisco's bug documents, you can get to know what vulnerable things can happen in that particular version. And someone can launch an attack or create a application to launch an attack for such things, okay, and can cause a DOS attack or can cause some SYN packet attack and put the device on a over exhausted mode, so the device will not serve or process the genuine packet too. Well, this is just loading. Let me see if it comes up. Cisco. So Cisco always launches this advisories whenever there is a security bundle, and it expect that users follow that. So see, there's if there is any issues, let's say Cisco iOS. See, there are some Cisco iOS XR software bootloader unauthenticated information disclosure closure vulnerability. Medium. This is the caveat, or this is the CV number, reference number, and the last update is this. So as per this vulnerability, the bootloader for the XR software can allow an unauthenticated attack with the physical address to the device to view sensitive file. So when you open up this, they will talk about mitigation process as well. So these are the bug relevant to that bug, or this impact was seen. So basically, bug means when, let's say, I as a customer, I got some issue, I raise a Cisco tag. Cisco tag will come to know that this is not a usual case. It's an issue with their iOS. They will try to track that with the certain bug ID. So next time if the same thing happens, or next time if there is a uh, you want to refer it, they will be referring to this bug ID. So as per the bug ID, they will put all the details that this was the customer environment, this was the hardware, this was the configuration that he was running, this happened when he was doing this. Everything will be detailed, as well as the information will be mentioned that this issue is seen in 17.1, 17.2. However, it is fixed in 17.3. So for that kind of reference, they keep this bug ID. You can see the security advisory here, that the security things, and also which devices that is been impacting. So on the ASR 9K, there this was identified. Might be there are some 10 ticket created under this bug ID. Similar way, it was impacted on these hardware. So are you falling under any of this? Right, so that is how the team behind will do the analysis and keep and make sure your iOS or your XCXR don't fall under any bug or don't fall under any caveat. If it is, then you have to prefer to do the bug analysis. So you have to go and check. Let's say you are having 17.6, you will check every possible bug and every possible caveat there, and then cross check if it is really impacting with your config, or you can ignore that. If you see that you have some features like OSPF, which you can't shut down, you have some features like BGP, which you can't shut down, but there is a caveat for that, then what is the mitigation process? If the tag say you have to upgrade it, then you have to upgrade to the next version. Okay, so that's about the firmware and software upgrade. No one upgrades just as such to another version. There is a team behind that to see which version they need to upgrade it. Okay, they go via the business BU recommended images, which is also called as golden image with the star, golden star. So you have to make an analysis that if that image is a perfect match for you or not. Okay, fine. So for the Cisco ASA firewall, pretty much the same thing. A AAA device logging, auditing, ACLs, IPS, IDS. Stateful, enable the stateful packet inspection. So basically, stateful is a feature where, let's say, if the packet has origin from the LAN, it wants to go out, right? So you will only write one security policy for that. Let's say this is the source and this is the destination, and you are interested to go to port 80. So when the return traffic comes, you don't need another bidirectional ACLs to be allowed, because your firewalls nowadays have the stateful packet inspection concept. So they know the records that this was the packet origin from this to this for this port number. Now this is the return traffic. So it will not be uh, needing another bidirectional. Plus, it will save you some unwanted uh, overhead also, because if there was a fresh packet, then they definitely go from the different steps. They will unnat the packet, they will check if it's a VPN traffic, they will go through the ingress buffer count increase. So few things can be avoided if you enable the stateful packet inspection. VPN and configure secure remote access, firmware, IPS, implement application layer inspection. So basically, this can refer to that proxy, okay, and anything related to the layer 7 inspection. So proxy works well. You might know that sometimes what happen on a browser, on the browser setting, they normally target your all layer 7 traffic to go to some proxy. So proxy, you might have heard about blue coat proxy, right? There can be some blue coat proxy where you have written the policies, what type of traffic can be allowed, whom to allow, etc., etc. So if you sense that someone is typing some URL which is not allowed, all the traffic will be going through the proxy now, and this will be this can be monitored, this can be analyzed, which user is accessing what type of website, and you can take the needful measures there. So you might have seen some proxy whenever you want to reach to internet, you might go to the setting and set some proxy, because there you might have written the permission that you can reach Facebook or YouTube or any allowed website. Not the non-allowed website would be just suppressed. It won't be enabled. Policies and the failovers. Okay, so these are some hardening method. I hope it is clear. I'll go to the next topic. Okay, these are something which you are supposed to do in your lab. I'll just show you what to be done. Just expand one step. So let's say you have few devices here. You have some routers, you have switch, you have firewalls, right? So wherever you see the router, see, router, switch, and firewalls, right? So wherever you see this config, you place it on a respective type of device. So you can power on router. This is a switch, and there is a firewall here, Cisco ASA firewall. So you just open all the three, bring the nodes. Let me show you how do you copy something to this console. First, go here. See, this is a securing management interfaces. Okay. So over on the line VTY, you know what is line VTY. If I want to take the SSH to the remote box, I have to configure the SSH protocol, right? So sometimes people allow telnet, sometimes it will be allow all, right? So I can just allow SSH alone for the line VTY. And if you don't need aux 0, console 0, you can also make it none. So this is one of the hardening method for the management interfaces. This is for the switch. This is for the ASA firewalls. ASA firewall has a different config. You will enable version 2 and you can say that no telnet allowed. And for the SSH, you can just you might be aware that you can put the uh, subnet that can only be allowed to perform you know uh, the things. You can say that this is on the management port, something like that. So ASA works bit different when compared to the router and switches. Here you have to tell which interface or which subnet you want to allow for the management or the SSH. Okay. Now what you have to do is just to see this config on the device, you copy that. Let's say this is your box. This is a router. I'll show you how do you copy paste on this nodes. See, there are two type of mode here. One is called HTML console, HTML, which is a browser-based console. The second one is if you disable this, you get the regular putty sessions. So you will click this, you get a regular putty session. You can directly copy paste here. Okay, but this is a non-multi-tabbed option. If you're okay with that, you can disable this option and get the regular console. However, if you want the multi-tab facility, you can enable the HTML console. But however, the copy paste will not be as similar to that regular putty. So if I want to copy paste anything to this, first let me go to enable mode. I'll go to the configuration T mode. I'll open the console, or I'll open the clipboard for it. That is with the help of Control plus Shift plus Alt. Control Shift Alt, I get this clipboard. There are three options here: none, text, and on screen. I'll select the text input. Now there is a blinking cursor over here. Over here. You can see a blinking cursor. I'll just right click and paste my config. See, something like this. Okay, so what do I have under line console? Transport output. So you can make it none if in case you don't want the console to be enabled. Or if you want, let's say, transport just SSH. Transport preferred. And also you can utilize the preferred command. Okay. So if in case you want to prefer R login, you can go with this. So this is how you can configure the configuration from the workbook. Okay. If you have a dual monitor, you can keep your workbook on one screen, and on the other screen you can refer and type it manually. If you type it manually, it is much better. But if you don't have dual monitor, then you can just copy this and paste it here and see how it behave. If you find any CLI mistake or anything, you can even check with the help of question mark. See the outcomes. You will get to know more detail about it. So this command is when you might have enabled 2-3 items. Let's say SSH, R login, and let's say telnet. Okay, telnet is not needed, but I'm just giving an example. However, with the preferred, you can say that you only want preferable SSH. So if in case SSH is not working, then as a backward compatible R login or the another protocol can also work. So define which protocol to use, specify the preferred protocol to use. So that is how you have to practice by typing over on the devices. So the first one was from the management interface, SSH enable on the line VTY. The second one is to set the strong password and enable AAA. Okay. The command might have some some variables. You need to change that. Say for example, this command in real world would have been something like this. You can't keep it like with this kind of dummy values. Okay, so put Cisco 123 username admin privilege 15, and what's the secret here? Let's say secret is 123, and this is to enable the AAA feature. So this is when you want to enable this secret, okay? Enable AAA or enable implement the strong password. You can give a try. You see what algorithms you get to here. So when you go with enable secret question mark. See, these are the different algorithms. Okay, in one of our class, we will discuss about the different algorithms and which one to use and which one to not use. These are the very outdated or very weaker one, MD5 message digest. They can be easily decrypted. So you can go with secret level 8 or you can go with secret level 9. So let's say I'm preferring to go with secret level 8, and then you can set that credential Cisco 123. Now what does it say? The secret you entered is not a valid encrypted secret. To enter an encrypted, do not specify type 8A. When you properly enter a unencrypted secret, it will be secret. It will be encrypted. So let's say you just remove this and put now. Okay, you can check under the show run. By default, what would have been taken? See, so by default, it would take type 5. But let's say I'm not interested in type 5 because type 5 is a message digest file, which is easily, decrypted. So in that case, you have to make sure that you are running secret 8. So let us see one more time. Enable secret 8. Let's say, yeah, that is because it is expecting us to give the encrypted format. Okay. So I'm not sure if I have anything encrypted with me. Let me see if I can create type 8 secret password. So I'll go to some online website. Let me search in the Google rather than Bing. Generate type 8 password. So there are usually the generators where I will put my password. Okay, this is some Python script to do that. See, there is way to generate also. Enable algorithm. Let's check if with this help can we do it. Enable algorithm type. Let's say if I go with SHA 256 secret, let's say Cisco 1234. Okay. Now let me see what all type of enable I have it. See, now I have secret 8, and you see this is the encrypted format. Now let's say if I copy this, okay, and go back, this was where I was trying to type. It will not take the exact thing, right? So that's why we will take a encrypted format. See, now it took this. I hope you got the reason why it didn't accept that time, because we were trying to add a plain text and it was asking us to put the encrypted format of that. So we went via other method. We said in this device, I don't want anything MD5. So I added this command. So with this command, whatever was there with MD5, it got converted to type 8. With that help, I got to know that my Cisco 123 password was having this encrypted format. So just to test purpose, I copied that, went back and tried to add, and it accepted that. Okay. So if you're going with 8, you have to put the encrypted password. And what is the actual password behind that? You can't decode it. If you are storing it somewhere, or you have some inventory management, or you have some management to deal with the password, you can store there. So this is very important at the time of even iOS upgrade, or at the time of let's say you are going to do a SNMP v2 to v3, or you want it for enable secret for any migration, because this password you can't decode it until you know the actual thing behind it. Okay, so that's a type 8 message here. Let me go back. So this is from the algorithm that it supports. Okay, and these are the single line. Cisco switch. How to enable logging and auditing. So you can enable the logging with logging buffered, logging trap information. For auditing, you can make use of any Cisco ISE or any software which can collect all the audit messages. This is to apply the ACL, which I know you guys should be already aware. So you will first put the access list and then call that particular access list under the respective interface on a in or out direction. Access list, standard number 10, permit, source, destination, protocol, interface name, and allow that or deny that depending upon what your access list looks like. So same thing with the firewall. This is outside interface, permit, TCP, let's say sources any, destination, you're mentioning the IP and port number, and you go to the interface level and prescribe that if you want to add this or you want to suppress this. Disable unnecessary service protocol. See, these are the some service protocol and services which you can disable it. No service finger, no service pad, no IP boot P server, no source route. Same thing on the switch and same thing on the ASA firewalls where you can disable this no service and no protocols. This is a template for the VPN. When we cover the VPN topic, we will check individually how it works. So for now, I've just given you the ICKMP property and the crypto IPsec properties, phase 1 and phase 2 property. This may not be a functional code. This is just a template where you understand what is what, okay? This is the command to enable version 2 and all respective platforms. And for the firmware, you can go to the download center and download the images. I believe you know how to download Cisco files. For the role-based thing, you can see here AAA authorization, execute default group, the group name, local, and you can specify the levels over here. So you want to give him a level 10 or 15 or based on his username. So let's say his name is this. So device like Cisco ICE, you can configure some role-based thing that if a person with this is trying to enter some device, let him be given a read-only role-based. And as per read-only, he can just view the things. He can't do any changes. So that's a role-based thing. Queue, server, default, group, and this one. For IPS and the other things, you need to have that module and then you can configure. Nowadays, we use a separate IPS module. You get this FTD boxes, which you can also use in the NG IPS model, which we also have in our lab. So there is one node over here, which is using the NG IPS. So you can monitor the traffic there. This is for the COPP, control plane policy. As I was telling, you can monitor the traffic first for 10 days or 1 month. You can see the rate of traffic that is being transmitted over on that interface and then write the policy. If you receive more than 8,000 BPS, more than this packet size, you can drop it or you can queue that. Okay, because all of a sudden, let's say you monitored for a month, you come to know 8,000 is your average traffic, but all of a sudden you are receiving 15,000 BPS or 20,000 BPS. So to have any negative impact, you can of course put the condition and mention above 8,000. If anything comes, then uh, just drop it so that it don't cause any issues with your devices. And to put any unnecessary port, you can go to the interface and just put the shutdown command. All right, so that is about the device hardening and what are the CLI commands to do that. So any doubt with that? So we have 30 more minutes. What we can do is we can go to next topic. Next topic is also more like self-explanatory. The labs are also mentioned here. I will tell you which portion you can, which section you can go ahead and do recreate this things. Okay. So we will talk about common attack. Now this is a topic which used to be in the CCNA security sometime back. But as you know, nowadays there is no CCNA security. So all its topics are being moved to the CCNP level as well. And you will see that in under the SCOR module. So common attacks, to understand, there is something documentation called OWASP top 10 attacks. Okay. So this is a community which keeps tracks of all the major common attacks and spread the awareness. So if you see from here, these are the few very commonly attacks that we see: broken access control, cryptographic injection, insecure design, security misconfiguration, vulnerable and outdated components, identification and authentication, software and data integrity, security, and server side request forgery. Now, not everything might be directly related to us, because what happens in networking side, we are having on-premise devices, right? This could be for the cloud based also. Cloud based in the sense, if I'm making use of SD-WAN, where SD-WAN is somewhere public facing, or I have a Epic which is somewhere. So this can be directly impacting that. But for the on-premise devices where I've kept under the rack, this may not be directly causing it. I might get attacks like STP attack. I might get a DNS attack. I might get a DHCP attack. I might have to secure my OSPF protocol. So the feature or the functionality that you have on your devices been running, there can be a backdoor possible. So you have to take care of from the protocol that is there on the on-premise devices. Plus nowadays, this is something which is there in almost every production. You might be having SD-WAN that works on the dashboard concept, which is a HTTP based. So you can find issues like the injection issues or database issue, or uh, the DB issue. So there can be even issues related to the dashboard. And for the traditional protocols, there can be even other set of attacks. So we will see both now. So when you talk about DDoS attack, what do you understand by distributed denial of service attack? So let's say I have my servers kept here, and all of a sudden I start getting all the different types of attacks from a different countries. So let's say I have from US, I have from Russia, I have Singapore, Australia, from all the different regions. The attacks could look like a simple SYN packet coming to you, and your server is busy responding with the SYN ACK message. Okay, now this is like a millions of traffic in very short span of time, using some scripting or any any hacking softwares. Now now the server will start degrading. It has no free memory to process the genuine packet, and it's all buffer tables, and the memory is all exhausted. So why people do this? Because to, degrade the services. Let's say you are running a company called XYZ, which provides the application usage, but for some reason XYZ company is now down due to some attack. So your competitor is in a gain, right? He's minting the money right now because your performance is degraded. So who knows, he might have had to do that, or who knows that your network devices are on a outdated and on a less secured platform, so that someone took that advantage and now he's asking you to give some ransom money, or so that he can release the things. So they might have different mentality. Some people come for a fun purpose, some does it for the money purpose. They can demand you the money. Some people can get hired to do that. We never know, but our thing, what we need to deal is how do we protect our network. So in the DDoS attack, the people will start doing a SYN flood. Server will start responding to acknowledge, and at one fine time, it is 100% exhausted. Now at the same time, your legitimate user who is a paid user, he is trying to establish the connection, and your server is dead. There is no response going. That is called a DDoS attack. Okay, whereas the DOS attack is also very similar, but from one single geographical region. So let's say you have one geographical region XYZ, and all the millions traffic attacks initiate from that single place. That's called DDoS. That is called DOS, simple DOS without DDoS. Whereas DDoS is when from a multiple countries all at once. So your IDS will start showing you you're getting an attack from Russia, you're getting an attack from another country, right? So that's called DDoS attack. Pretty much same, but just from where it's occurring. Man in middle attack is very common terminology. So man in middle normally sits over on the ISP. So if you don't make use of a secured VPN tunnel, that person will try to decode the traffic and try to see what is this traffic for. He can be acting as a ROG device, pretending it to be yourself. However, he is not the genuine person. So that is called man in middle. And under the man in middle, you have some examples like Wi-Fi scenarios or a ARP poisoning. So ARP poisoning is also very similar as a man in middle. So let's say normally what is ARP address resolution protocol, right? Say for example, this is a Bob. You just put the FQDN. It should resolve to that MAC address. Let's say this FQDN resembles 192.168.1.1. So what is the MAC address of that particular device? So that's called ARP, IP to MAC resolution. Now these are the legitimate users. But for some reason, the man in middle at person comes here and he pretend to be that particular user. Might be he say that I'm the user. You can see here R catch modified to this dot five. Dot five is this guy with this MAC address. Now he is telling that to this person, I am dot five and my MAC address is this. Similar way to this person, he's saying, I am dot one on behalf of this, and my MAC address is this. Now, what happens is the ARP table gets updated. Now, the anything has to be sent across this will be sent now over on the hacker's machine. Hacker will be running any packet analysis software and will be able to see what type of packet and the information. He might pull some target releases. He can pull the password that you might be entering here. So this is called a ARP spoofing attack, which is part of man in middle. So similar way, there are STP spoofing. Okay, so these are the three types in the man in middle. Let's see to the next one, which is brute force attack. As the name say, someone trying endless or possible combination to match it. That's called brute force attack. So password cracking or SSH brute forcing, or this is the wireless thing when people try to, enter all the possible combination. So you can set the condition here. If you receive, let's say in 5 minutes, you receive someone trying for the 10th time. So put him on a silent mode for next 30 minutes. You might seen this in your mobile also. So if you try to enter wrong password on your Android or iPhone, it will go on some go on some restriction mode for next 10 minutes, for 15 minutes. You can't enter the credentials. So that's a type of brute force attack. Uh, Phishing attack. This is this is basically when the social engineering attack like Facebook method or Instagram method is being followed. Okay, Facebook, Instagram, or even website, or even your Gmail or the mail accounts. So what happens here is you receive an email as if very genuine thing that you have won a lottery or something, and to claim that they provide you a link. That link might take you to a website, and that website could be a very look like of some legitimate website. Say for example, you have something from the government xyz dot gov. So this website might be a clone of this, but however not from the .org. Might be they might be using some other thing like this. Not a genuine website, but with certain thing, and might be they do not have a secured lock pad and etc. But you out of curiosity or with the least patience, you just go to that website and mention all your detail, your name, your date of birth. Might be they ask you more item, and those information will be reached to that spammer or that hacker. Now he has your credentials and he can log into your mail. From the mail, he can check all the other various details, and they can steal your money, they can steal your data and start threatening you. And a lot of things can happen. So those kind of attacks are usually being caused by email or website or spear phishing attacks. Malware attack. Malware usually are called as a piece of code or software which is written and in a way of the downloaded file that gets infected to your machines. So these are some software coded viruses. So I can write a virus and I can say that when someone and I will insert in this package a small file So when you install this package, I will say that this virus has to corrupt all the files of my system. Might be if I have Notepad, I will start seeing some extension visible to it. When I try to open, it will say that this application is not present. When you try to remove the extension, it will reappear the extension. So it don't let you to open any file. And the only solution is either you run antivirus. If it is really successful in order to remove, good. Otherwise, you have to re-trigger the operating installation, reinstall the operating software. Malware attack. So you can have expect something called ransomware, malware that encrypts victim file and demands a ransom in exchange of decryption key. You might have seen sometime your machine gets locked. Okay, and the machine says that this machine has been hacked and will not be able to use. If you want to unlock it, you call at this number. And when you call them, they say, yeah, we can give you the credential or decryption key, pay us so and so money. So if you really think that machine is worth, there are a lot of confidential data and very important files, you might end up paying. But if you think you don't, you can just reinstall the things. You might lose everything, but if that's okay, you can go with that. Trojan house, Trojan horse, sorry, malicious software disguised as legitimate software. So you are having a software, as I was telling, you just downloaded a MP4 software, but who knows, there is a disguised file to that. Say, for example, you downloaded VLC player, okay, from a non-legitimate website. You never know what that VLC application is consisting. That can have some other Trojan horse codes that can go and impact your laptop, which can infect your laptop. Botnet, malware that infects and control the multiple compromised devices, forming a network that can be used for various malicious activities such as DOS and all those things. So this is a software coded viruses, malware attacks. SQL. This is now respective to your the front end things like DNAC, SD-WAN. Why? Because SQL is a database. You might have heard about MongoDB, SQL, MySQL. These are all database, and this comes in picture with more like HTTP based, protocols. Now here the database can be corrupted, right? Let's say if you have a database of all your customer, what if I steal that and sell it in eBay, or I sell it to a vendor, and all your customer will start receiving all the spam calls and all those things, or I delete those tables of DB, then you will lose every other information of that. So people who will attack your SQL, okay, web application, to inject the malicious SQL to manipulate or retrieve the unauthorized data from the database. This is a serious threat and issues. Again, this is also from the HTTP web page concept. Cross-site scripting. This will inject the malicious script on the web pages, allowing them to execute arbitrary code within the victim's browser and steal the sensitive. So, like I was telling, some look-like application, right? So I will create that, and I will ask them to enter the credentials or enter the information, and I will receive it on my machine. Cross-site scripting. Insider threat, an attack or security breach caused by individual with authorized access to the network who intentionally or unintentionally abuses their privileges. Say, for example, I unauthorized data access. An employee with privileged access intentionally access sensitive information without proper authorization, potentially leading to data breaches. Say, for example, I have a server, all my confidential data is kept here. Since I'm an employee here, I might be having the access to this. Now, I might be a person who wants this to be with me so that whenever I leave this organization, when I go to another organization, I can utilize that videos or that application. But where am I storing this? I might be storing in a very least secured folder. Now, what if that got compromised? So I am making a mistake of keeping some confidential files with me on a very least secured folders, which got compromised or which got leaked. And now those are in the torrent website. So who is responsible? The person is responsible for his negligence. So these are like insider threat. You have the access, you kept somewhere, then someone steals it from you, it becomes an insider threat. Data leakage, sabotage, an employee with insider knowledge and access intentionally disrupt or damages network infrastructure data, causing harm to the organization. You might have heard some recent news as well. It usually happens across the borders of two countries that some people are selling some data information to the militant or the armies of the different country to get some paid for that. So that kind of thing it is. Zero day exploit, an attack that takes advantage of vulnerability in software or system for which no fix or patch was available. See, for example, you just purchased a new box. You, let's say it's a SD-WAN. You have got it with this. You just installed it, you are having all the things, but you never knew that this code was being exploited, and you should not have bought this in production without being upgrading to 22 series. You didn't know that. You just are using it. That's called zero-day exploit. Because most of the time when we buy those devices, they usually will be running on very outdated version. So first time when you connect to internet, it automatically asks you to upgrade it to the latest version. However, sometimes if we don't or we ignore that messages, we might fall under the zero-day exploit. Attacker discover the previously unknown vulnerability. Threat actors use zero-day exploit to gain the unauthorized access and all these things. Social engineering, I've already told you, you might get a text, you might get a phishing phone calls, dumpster things, might give you a website, might give you some, link to click and expect you to enter the information, and that is how they steal the information and get the things. SQL, as the name says, we might face issue with the database, which can cause database leakage or the customer information leakage. Okay, and the cross-site scripting attack. So this we already checked it. So I'm going to go to the next slide. Let us see what we have. The next slide is basically the lab demonstration for what we did there. Okay. You can follow this lab demonstration. I'll just show you which notes you need to open for that. Let's say you wanted to practice STP attack and mitigation process, right? What is STP? Spanning tree protocol. Now, what kind of attacks that we are talking about? Let's say I have three switches. This is the root bridge. These are, let's say, the root port. Let's say one of them goes in the blocking mode and other one is in the forwarding mode. Now, what if I have another ROG machine? Correct? Now that is sending the superior BPDU. Might be you're not using BPDU guard and root guard and all those feature. Now what will happen is this will lose its root bridge capability and this will take up the root bridge. Re-election will happen. Might be now the scenario is different. Now all that information, CDP, LLDP, DTP, BPDUs, this guy is also getting that information, and he is able to see what type of packet, what type of device target images that you're running. So we need to stop that. We don't want such scenarios where where a switch gets connected and take up the role of this, right? So two things we do in the lab here, security lab. One is we generate the attack. For that, we use the Kali Linux and its application. And second thing is to know what is the mitigation process. How do we do the mitigation process? So first thing, what I have done is I've given a small background about it, like what is the use case, or what is the reason for this kind of attack, and what is STP and etc. Then the diagram of the same. You can find the Kali Linux over here. You just have to enable this. You have a switch directly connected, so you can easily cause an STP attack to this. Okay, you follow the workbook, and this is the application that you will open. It's called Edsenia-G. When you open that application, you can enable all this type of attack. Now, the attack that you are going to launch is to claim the root role. So you want to become a root switch there in the network. And when you do the spanning tree, might be you have lost your root bridge criteria. No more a root bridge. A root bridge is taken over by the Kali Linux. So you can check that. So you have to check that. Now the last step is the mitigation process. So under the STP, you go back to your encore. If you don't recall the STP, you see what are the things that can be enabled: port fast, BPDU guard, root guard, and loop guard. What do you mean by that? So you can enable BPDU guard, you can enable root guard. So if you receive any superior BPDU, immediately the that switch port will go into the error disabled mode. That's the mitigation process for STP. Okay, so enable the BPDU, enable the root guard, enable the loop guard. So that is your first lab. So very simple. You may not be aware how to perform this, so that's why I just gave you an overview. One second. So when you see that no bootable, let me try with wiping this. I can see the right image. Okay, what is the CAM table overflow? CAM table is content addressable memory. Okay, it is basically the memory of that application. So if I do a attack on the CAM table, uh, sorry, yeah, so basically what happens is, if let's say I create some MAC address inconsistency on inside the switch. So let's say a switch has capability of 1000 MAC address at a time, but I launch an attack of 1 million. Now what happens is my switch performance degrades due to the very high MAC address reading. And also chances are that the genuine ARP table is all flushed with the all a fake MAC address. You can see that in the before status, you have a MAC address, only single MAC address, right? But when you launch the attack, again the same process, switch and the Kali Linux, you will make use of the terminal to launch this attack called Mac OF-E0. E0 is nothing but the interface ID of that Kali Linux. Now when you do that, you will see, okay, I think the screenshot is not taken. You will see that the MAC address table is all flooded with thousands of fake addresses. So you can see the list of thousands of this. Your switch is very, very slow. The legitimate MAC address are being flushed out. These are all the fake IPs or fake IDs. So by default, it will take 300 seconds to flush them. 300 second is like what? If you divide by 60, almost like 5 minutes. So a 5 minute of straight outage, correct? So that is called CAM attack. To mitigate the process, you can enable the port security. You can mention that I only want this MAC address on that interface ID. But if let's say that is not possible in the protection, how can you give a static MAC address on that switch ID, right? But you can still go with a number of things. I can go with maximum 4 MAC address, any 4 MAC address, but not more than that. If I go and receive more than 4, then might be I have a protect mode. That means that switch port will go in a error disabled mode, something like that. So this is called a port security, which is done on the switch interfaces. Okay, whenever there is a violation for the port security, you can see the interface will get into the violation of that. You can enable the auto discovery if the issues is rectified, because there is a auto aging, right? So after 300 seconds, the things will be rectified. Okay, there the next one was CDP LLDP reconnaissance. The reconnaissance word means when someone is continuously monitoring the pattern, monitoring for a very long time, and then making the attack on those devices. So here in the CDP LDP, since all the neighbor information will be carried upon, this packets can be monitored, and then see what all information that CDP packets will take. Right now we recreate the same thing. We go to the Yersinia G and we will cause a CDP packet flooding the CDP table. So when I flood the CDP packet, which is again a a multicast based MAC address will be present, you will see the switch is hung now. There's no resource left for your genuine packet processing. So how do you mitigate the process? As we just saw in our initial slide, we can disable this if you think this is not needed for you. So to disable that, you can take the precautionary action item, no CDP enable, and put them down. Okay. Same way, DHCP snooping. You know how the DHCP work. There are 4 processes: DORA process, discover, offer, request, acknowledgement. There is a DHCP server, there are DHCP client. Now let's say the DHCP server is being replaced by a ROG DHCP server. And also remember, DHCP also gives something called DNS information to all the client as well. Now the ROG machine is going to give a DNS, but to the hackers DNS services. Now, what is chances? Say, for example, here the DNS for Google was resolving to a certain IP, let's say 211.1.1.1. Now, what if the person has been redirecting that to 1.1.1, and there he has created a look-like of Google page? Now, you will think it's a legitimate website and put down all your credentials, and he will get all the things that he wants it. Now, to mitigate the process, we come up with the concept of DHCP snooping. So spoofing is attack. Okay, you can see what is spoofing. when an attacker attempts to respond to the DHCP request and trying to list themselves as the default gateway or DNS server, hence initiating a man-in-middle attack. With that, it's possible that they can intercept the traffic from user before forwarding to the real gateway. Okay, spoofing is the attack, and the mitigation process. So I've also done the lab here, so you can also recreate it. This is the DHCP server configuration, and you can see here I've put the needful configurations here. And from the VPCS, I will make use of DHCP. I'll get an IP. However, if I go to the Yersinia once again, and I make a discover packet, DHCP sending discover packet. So now what will happen is I'll put the parameters also, sir. DHCP discover. I'll say that this is server ID, this is this, and you see I've also mentioned my DNS where I'm going to host my web pages. Now Kali has not started forwarding request to enable the forwarding request. So when you enable this thing, DHCP spoofing, now you see you get that IP fulfilled by the ROG devices. So you have a pool here, right? You're getting that pool here, which is not good because now all the request goes to that attacker's DNS and he might be having a look like or a clone of the actual web pages. So DHCP snooping is the mitigation process. So people get confused. If you see DHCP spoofing, that's an attack, and DHCP snooping is called the mitigation process. So you can configure the trust point. You can say that you are looking for the uh, trusted DHCP over on this interface, and anything coming on a different interface is non-trustable, and you can just shut it down, or you can just uh, disable that port. So that's a DHCP snooping. VLAN security, it's a private VLAN. Okay, I think we will take this in the next class because it's already 11:13. We started by 9, right? 9 to 10, 10 to 11. Yeah, so been 2 hours and plus. But I would advise you can just go through this initial labs because they are easy to crack. Basically, a CCNA portion normally. So there are three types of planes. This is the securing the management plane, securing the control plane, and the data plane. Okay, and a comparison chart of in-band and out-band. You know what is in-band? So let's say if I have a device and this is my data port, let's say gig 0/1. If someone is making use of the same link or same plane or same interface or data plane or data VLAN for the SSH as well. So that's called a in-band management. But we don't use our data VLANs for SSH. We keep it out of band. For a management purpose, we make use of a separate VLAN itself, where only the management is kept. A separate network, more secure as the management traffic is isolated from data traffic. Yeah, expensive because you need a separate cables and all those cabling process. And this one, okay, in-band management and out-band management. Yeah, one last topic that is about securing routing protocol. You all know the routing protocols like RIP, EIGRP, OSPF, and BGP. Correct. Now you also know that they comes with the authentication mechanism. Might be in the enterprise level, you might not be doing it, though it is there. you might always just enable the things. You go to router OSPF and put the needful thing, but you never enable the authentication. So there is a authentication step where it supports all this major algorithm, and it is advisable for you to have this in your production along with the regular one. So that is what is being documented here. So this is a regular EIGRP configurations, but you can enable the key strings or the protocol. For just lab purpose, I am just making use of this, but it is advisable to have something better like 256. So now what happens if in case you have two routers, you can see the EIGRP packet being authenticated with the SHA 256. So rather than someone able to decrypt your packet. Same with the OSPF. OSPF also have the set of algorithm that it supports. So how do we check what type of things it support? You can just take this config. So let's say we just go on to a single device. Okay, this is ASA. Let me go to router. Conf. Okay. This what is the password I gave? Cisco 123 123. Yeah, this is because we had typed some password. I don't recall what I gave. Okay, let me just switch off and switch on. And meanwhile, I can open the switch. The switch should be ready. Yeah. Now let's say if I go to a conf t, and usually I enable the OSPF and the process ID, I just put the network statement 1.1.1, the wildcard mask, area 0. Okay, yeah, why this process has not initiated, because we don't have either router ID or interface ID, or we have not specified any loopback. So let me also, for a sake of config, let me just mention that we have some IP address on the device. No shutdown. Okay. Okay, it's a layer 3 switch. So first make no switch port and then add the IP addressing. Okay. Now, if you go to the interface level, let's say E0/2 and go to IP OSPF authentication. Now you see you have message digest. Okay, one of the mechanism. You can also have other factor. Let me see that. Authentication key. Yeah, here you have up to 0 to 7 encryption method. Okay, and you can set the password here. So it is expecting the key here, that encrypted format key. So let us check what other algorithm it do allows us. So you can go with the no authentication. You can go with message digest, keychain. And this is when you go with the key chain and you just call it over here. Might be under the key chain you can find some more levels. So how do you create a key? So you can go to key chain and configure a key first. Key chain, just give a name, question mark. Now over here you can configure a key first, get inside that. Now you can see the cryptographic algorithm and question mark. Yeah, see you have all the stronger one now. So you can go with SHA1 256 384 512. This is not much better. You can go with this and set your key. Let's say HMAC 256. The key is set. Come out of this. Now go to that interface wherever you want to add this particular key, IP, OSPF, authentication. IP, OSPF. Okay, 1 second. Let me say 0/2 authentication. Now you have a keychain option. Keychain and the word that you utilize to configure that. So let's say Cisco. Okay. Now you're making use of a better algorithm. Though OSPF gave you a simpler option as well to go with MD5, you need not to have to create keychain. You could have gone with MD5. But MD5 is again something a non-compliance nowadays in the production. So you go and create a keychain, associate a better algorithm, and then call it on the interface level. Now, whatever OSPF packets are going out, they will be encrypted with the help of this algorithm, so that no one in the a man in middle can decrypt and can read what were the things or read the packets around. So that is about securing the protocol. Now, we will wrap up here. What you guys have to do is go back, read the material, and there are the labs. Go and follow the labs. There are all steps being described here. Try to do some labs here. If there is any issues with the lab or with the copy paste or with any sort of things, you can make use of our WhatsApp group, and I'll be guiding you with how to deal with that. Okay, so we will wrap up here at the securing the protocol. Next class, we will continue with the next topic that is somewhere from here. Okay, so any question before we wrap up?
Yes,
Alrighty.
Sagar.
Yeah.
One quick
Yeah.
question. Um, is that the next class on next Sunday?
See, actually, that we might go for a very longer period. I know during the Cisco eyes, I was keeping it only Sunday because it was a wider session. Like I used to keep like this. But now the problem is I am having Saturday and Sunday already some classes till this 6 to 9 I have it. So I'm only left with your SCOR topic from 9 to 11 on 2 days. So if I don't utilize one day, then a week of 2 hours will be very slow progress and might take a lot of time. So I think I have to take Saturday as well to complete it in a 2 to 3 month basically. Okay, so I have to go with the I have to take the class on Saturday. I don't see any other way to handle. Previously, I was taking Saturday for another batch for 7 to 11, and the security I was taking only on Sunday 7 to 11. But nowadays, they want on both the days. They want Saturday and Sunday. So I'm only left with 9 to 11. And if I keep only for one day, that would be a very lengthy duration to complete. So I'll go with
So
Saturday as well. If there
yeah,
is possibility, you can join. Otherwise, you go through the recording and Sunday class, you can clear your things.
okay. So is
Okay.
that possible? Like Saturday little late, little early or something?
Okay, you let me know what time. I will check if that is doable. Okay, but as I told you, 6 to 9, I will be having a different session. So if there is any plus minus 15-20 minutes, we can see, or 30 minutes something we can try.
Okay, fine.
Okay. All right. Have a good day. See you in the next weekend. Take care till then. Have a good day.